Welcome. This is a worksheet based upon integration and some special cases. What are those special cases? Let me write it out over here. A special cases formula. The special cases are you have any function in the denominator. You take any function in the denominator and its derivative should be present in the numerator. Then the formula is ln denominator. Rather than doing by substitution, this is going to be the easiest way. Means, for example, if I take any function x squared plus 3x plus 7, what is its derivative? Its derivative is 2x plus 3. Then the answer has to be ln of x squared plus 3x plus 7. So that should be the case. Take any function in the denominator, it works even with trigonometric functions. If at all I have sine x in the denominator, then its derivative, what is its derivative? Cosine x should be there in the numerator. Then the answer is ln sine x. Basically, cosine x upon sine x is nothing but what? Cotangent x. So this is a new formula, we have derived it out. Integral of cotangent x equal to ln sine x. So derivative of denominator should be present in numerator. Sometimes the next formula is nothing but what? I take the function without the denominator, it is in the numerator, but having a power n, and its derivative without the power n, and its derivative without the power n. Then that will be that function to the power of n plus 1 upon n plus 1 plus c. So what does that mean? I take any function x squared plus 3x plus 7 whole to the power of 8 I take, and without the power 8 its derivative 2x plus 3. Then what's going to be the answer? X squared plus 3x plus 7 whole to the power of 9 upon 9 plus c. That's going to be the answer. So take any function without the power, its derivative should be present, then whole to the power of n plus 1 upon n plus 1. So these are the two formulas that we are going to use it out for this worksheet or for this video. Now we see the denominator is x squared plus 4. Its derivative should be present. So what do? Multiply and divide by 2. So it becomes 1 upon 2 ln of x squared plus 4 plus c. Same is the case, e power 2x plus 1 is the denominator. Its derivative is 2e to the power of 2x. So multiply and divide by 2, 1 upon 2 ln of e to the power of 2x plus 1 plus c. Now it is whole power 3. So what am I going to do it out? I'm going to rewrite this one. X times x squared plus 4 whole to the power of negative 3. Now the power is negative 3. Now what is the derivative of x squared plus 4? 2x. So multiply and divide by 2. Now what should be the answer? 1 upon 2. That function whole to the power of n plus 1. N is over here minus 3. So minus 3 plus 1 is negative 2. Negative 2 upon negative 2 plus c. So what does it becomes? Negative 1 upon 4 x squared plus 4 whole power negative 2 plus c. Now the same is the case. Bring that e to the power of 2x plus 1 whole to the power of negative 3. Now e to the power of 2x plus 1 derivative is 2e to the power of 2x. Multiply and divide by 2. So 1 upon 2 e to the power of 2x plus 1 whole to the power of negative 2 upon negative 2 plus c. So what does it becomes? Negative 1 upon 4 e to the power of 2x plus 1 whole to the power of negative 2 plus c. Now 3 plus sine 2x. Sine 2x derivative is 2 cos 2x. So 2 is missing. Multiply and divide by 2. So 1 upon 2 ln of 3 plus sine 2x. So take a function in the denominator. Its derivative should be there in the numerator. Now whole power 3. So we can't use that formula. So rather than what do? Bring that to the numerator. Sine 2x. 3 plus cos 2x whole to the power of negative 3. Now cos 2x derivative. Cos 2x derivative is negative sine 2x. So negative is missing, minus and minus. And moreover 2 also. So multiply by 2, divide by 2. Because cos 2x derivative. What is cos 2x derivative? Negative 2 sine 2x. So multiply and divide by 2, negative 1 upon 2. So this entire thing is that formula. 3 plus cos 2x whole to the power of negative 2 upon negative 2 plus c. So what is going to be the answer? 1 upon 4. 3 plus cos 2x whole to the power of negative 2 plus c. For this question number 7, there is a new formula, e to the power of f of x. You take e to the power of f of x times f prime x. Take e to the power of f of x, any function, times that function's derivative. Then it will be directly e power f of x plus c. So e power any function times the derivative of that function will give you e power f of x. So here x square derivative is 2x. 2 is missing, so 1 and multiply and divide by 2. So answer is 1 upon 2 e power x square plus c. Question number 8. Sin 2x derivative is 2 cos 2x. So multiply and divide by 2. What is the power? 4. So it becomes 1 plus sin 2x whole to the power of 5 upon 5 plus c, which is 1 upon 10. 1 plus sin 2x whole to the power of 5 plus c. Question number 9. Secant square x tan square x. So it can be written as tan x whole square times secant square x. Now tan x derivative is secant square x. So the power is 2. So it becomes tan x whole to the power of n plus 1, 3 upon 3 plus c. That's going to be the answer. Next, question number 10. 1 plus tan square x times secant square x dx. So for this, what should I be doing it out? Now, in this case, what am I doing to do? Which is f of x and which is f prime x, that you need to decide it out. So for that, what am I doing is, so we will be know that tan x derivative is secant square x. So our intention is nothing but what? Tan x derivative is nothing but what? Secant square x. So over there, that concept has to be used. So what I will do, multiply secant square x times 1, secant square x times tan square x. Secant square x times 1 is secant square x dx, then secant square x tan square x. What is integral of secant square x? Is tan x. Now over here, this can be written as tan x whole square times secant square x dx. So which is tan x plus, this becomes tan x derivative is secant square x, so power is 2, so it becomes tan x whole to the power of n plus 1 is 3 by 3 plus c. Question number 11. We know that x square derivative is 2x. 2 derivative is 2, so multiply and divide by 2. So it becomes 1 upon 2 x square plus 2x plus 3 whole to the power of 5 upon 5 plus c. So 1 upon 10 x square plus 2x plus 3 whole to the power of 5 plus c. Coming to question number 12, cosecant square 2x cot 2x. So let cot 2x derivative is minus 2 cosecant square 2x. That's the formula we need to remember. Cot 2x derivative is minus 2 cosecant square 2x. So 2 is missing and minus 2 is also missing. So multiply and dividing by negative 1 upon 2. So what does that becomes now? Negative 1 upon 2. This is whole to the power of 1. So it becomes cot 2x whole to the power of 2 upon 2 plus c. So it is negative 1 upon 4 cot square 2x plus c. Question number 13. So over here we can see that sine 3x whole to the power of 5 times sine 3x derivative is cosine 3x times 3. So multiply and divide by 3. So 1 upon 3, what does it becomes? Sine 3x whole to the power of 6 upon 6 plus c. Question number 14. So for this we just learnt a formula, integral of e power f of x times f prime x will be e power f of x. So f of x is sin x. Sin x derivative is cos x. So answer is going to be e power f of x. So e power sin x plus c. Question number 15. Derivative of denominator should be present in numerator. Denominator is e power 2x plus 3. Its derivative is 2e power 2x. So multiply and divide by 2. 1 upon 2 ln e power 2x plus 3. Now again, x squared plus 1 is f of x. Its derivative is 2x. So multiply and divide by 2. So 1 upon 2, x squared plus 1. 3 upon 2 plus 1 is 5 upon 2 upon 5 upon 2 plus c. So 1 upon 2, 2 upon 5, x squared plus 1 whole power 5 upon 2 plus c. So 2 cancels. This is going to be the answer. 1 upon 5, x squared plus 1 whole power 5 upon 2 plus c. Question number 17. X squared derivative is 2x. X derivative is 1. 5 derivative is 0. So no need to write. So this can be written as, it's already there, derivative. So x squared plus x plus 5 whole to the power of 1 upon 2. So what does that becomes now? X squared plus x plus 5 whole power 3 upon 2 upon 3 upon 2 plus c. So what does that becomes now? 2 upon 3 x squared plus x plus 5 whole power 3 upon 2 plus c. Now this time what am I going to do? Bring that x squared plus x plus 5 to the numerator. X squared plus x plus 5 whole power negative 1 upon 2. So again, do I have x squared derivative? 2x. X derivative 1. So therefore, it is in that form. X squared plus x plus 5 whole power negative 1 upon 2 plus 1 is 1 upon 2 by 1 upon 2 plus c. So it becomes 2 bracket x squared plus x plus 5 whole power 1 upon 2 plus c. Finally, question number 19. Cos 2x derivative. What is cos 2x derivative? Negative 2 sin 2x. So what should I do? Multiply by 2, divide by 2. Why I am multiplying and dividing by 2? 2 sin x cos x will become sin 2x. Then cos 2x plus 3 whole to the power of negative 1 upon 2 dx. But I want negative sin 2x, right? So negative, negative. But I want negative 2 sin 2x. So therefore, multiply by 2, again divide by 2. So first multiplying and dividing by 2 is because of what is this? Converting into 2 sin x cos x as sin 2x. Next one is nothing but what? So that cos 2x derivative is 2 sin 2x. So what does it becomes? Negative 1 upon 4 cos 2x plus 3 whole power negative 1 upon 2 plus 1 is nothing but what? Positive 1 upon 2 divided by 1 upon 2 plus c. So it becomes negative 1 upon 4 times 2 cos 2x plus 3 whole power 1 upon 2 plus c. So 2 times 1, 2 times 2. So negative 1 upon 2 cos 2x plus 3 whole power 1 upon 2 plus c. That's going to be the answer. Now finally, we may try one more question, 20th question. Integral of sin x cos x. This time without square root. Cos 2x plus 3. Again cos 2x derivative. What is cos 2x derivative? Negative 2 sin 2x. So I want sin 2x. So multiply and divide by 2. So it becomes 1 upon 2 sin 2x upon cos 2x plus 3. But I want negative 2. So multiply and divide by negative 2. So it becomes negative 1 upon 4 negative 2 sin 2x divided by cos 2x plus 3 dx. So it is in the form of derivative of denominator present in numerator. So ln denominator 3 plus cos 2x plus c. This is going to be the answer. So these are 20 questions based on two specific formulae. So what are those two specific formulae? You need to revise it out. Those are integral derivative of denominator should be present in numerator, ln denominator. If it is in numerator without n, if at all a function has its derivative, then hold that function to the power of n plus 1 upon n plus 1. See you in the next video. Bye.